What's up everyone, Patrick here, welcome back. Moving on to another question dealing with quadratics. So we're asked for what values of A, B, and or C does each of these quadratics here have only 1, 0, and then we have to sketch each possibility. So before getting into these specific quadratics, I want to quickly do a review of a quadratic that only has 1, 0. What are some characteristics of a quadratic that are like that? We've discussed these a lot of times in previous videos, but a little review doesn't hurt. Well, first off, graphically, if a quadratic is only going to have 1, 0, it means that the vertex is on the x-axis. It also means the vertex is that 1, 0, that one x-intercept. So it could maybe look something like this, or it could be opening down. It could be opening down over here, right? Many different ways, but the point is, whether the quadratic opens down or opens up, the vertex of it, whether it's a maximum value like this or a minimum value like this, it's always going to be on that x-axis, okay? And then that vertex is going to be the same as that one x-intercept. Okay, so that's what graphically happens. And then also, algebraically, what happens if you have a quadratic that has 1, 0, remember, it's always going to be a perfect square trinomial. Meaning that it is only going to have one factor. Right? When you factor it, it's going to have one factor. So when you factor a perfect square trinomial, it's just going to be one factor and it's going to be squared. That's where that x-intercept, that one x-intercept is coming from. It's coming from that one factor. Right? So all of these here, all of these quadratics, if they're only going to have 1, 0, all of these are going to be perfect square trinomials. So that's key to understand, because that's what we're going to be using to solve these questions. All right, so just a quick review of what happens when a quadratic is 1, 0. Now, with a perfect square trinomial, we've gone through this in previous sections. Remember, there are two cases for a perfect square trinomial. You can either have m squared plus 2mn. When we went over this, I may have actually used a and b here, but I don't want you getting confused with these a, b, and c values, so I'm just going to use different letters here. It doesn't matter which letters you use over here. But if you remember, this factored into m plus n squared, right? We used this formula, this perfect square trinomial formula. And then also, this could be a plus or minus over here. So this could be a minus as well. So we could have plus or minus. So what I'm actually going to do, let's actually erase these for now. I'll bring them back as the video goes on. I just want some room over here. So let's write out both of these formulas here. So we have either plus 2mn plus n squared, and that's going to factor into m plus n squared, or we'll have m squared minus 2mn plus n squared, and that's going to factor into m minus n squared like that. Okay, so what b value would allow this quadratic to have only 1, 0? Well, it's going to be the b value that's going to make this quadratic a perfect square trinomial. So if we take this, write it right under this, so we'll have x squared plus bx plus 49, like that. Remember, how do we do this? Well, we match these up. So notice that the m squared has to equal the x squared, the 2mn has to equal the bx value, and then the n squared has to equal 49, like that. And so from here, it's kind of mix and matching. So notice from here, we can tell that if we square root both sides, the m value is going to equal x. Okay, so that's 1 that we got. And then over here, we can also get this. So n squared is equal to 49, square root both sides. Notice that n can either be plus or minus 7. So there's actually going to be two cases over here. And then we could take this m value of x and this n value of either plus or minus 7, plug it in here, and then we can get that b value. So again, there's going to be two cases. So the first case is going to be 2 times that m value of x times that n value of positive 7. That's going to be bx. So notice here we'll have 14x equals bx. So it's obvious to tell here that b is either 14, or if we let this be negative 7, so let's rewrite this, 2mn is equal to bx, so we'll have 2 times, the m is the x, and then we'll have an n value of negative 7, that's the other case. We end up with negative 14x, so b can also be negative 14. So that's actually the answer for this first one. So b can either be plus or minus 14. Okay, and the way we got those values is we basically matched the perfect square trinomial formula with the quadratic that we're working with, and we had to figure out what b value is going to put this quadratic in that perfect square trinomial format. Well, notice we were able to get the m value of x and then the n value of plus or minus 7. So then we could take those two values, plug it in for m and n, and then get that b value, right? Which we got over here and over there, like that. All right, so the answer to part A is b can be plus or minus 14. And so plugging that in, we'll have x squared. Let's say we got plus 14x plus 49, or we can have y equals x squared minus 14x plus 49, like that. Okay, and this over here, if you factor it, it's a perfect square trinomial. It's going to factor into x plus 7 squared. This is going to factor into x minus 7 squared, like that. And so we end up with two different quadratics here. This one here is going to have a vertex at negative 7 and 0. It's also going to have a y-intercept of 49, this c value. So let's just plot that to make our diagram have a little bit more detail. So this quadratic looks like this. Notice it only has 1 0 at negative 7 and 0, right? An x value negative 7 here is going to give us a y value of 0, meaning it's an x-intercept. And then over here, if we have x minus 7 squared, that's just basically going to be on the other side. It's going to be positive 7 and 0. Same intercept, like that, right? So we end up with those two quadratics. So those are the two different possibilities. When the b value is 14, when the b value is negative 14, then this quadratic is going to be a perfect square trinomial, meaning it's only going to have one factor. Then moving on to part B, so we got y equals negative x squared plus bx minus 16. Now with this kind of quadratic, notice there's a negative here, so the first thing I'm going to do is I'm actually going to take out a negative, and so it's going to change to this over here. And again, if it's only going to have 1 0, we want this bracket to factor into one factor squared, like that. Okay, so this quadratic in the bracket, the remaining quadratic, so let's write it. It has to be a perfect square trinomial. And so again, we can match it with that perfect square trinomial format. So the one I'm going to use here is going to be minus 2mn plus n squared, because this is a negative here. Match up the negatives. And so again, notice that the m squared, this, has to equal the x squared. Okay, this negative 2mn has to equal the negative bx, like that. And then this n squared has to equal the 16, right? So from here we could tell m is equal to x. From here we could tell n is equal to plus or minus 4, like that. And then we could plug in this m value of x and this n value of either plus or minus 4 here to solve for that b value. Now, first thing we could do actually here is we could divide both sides by -1 to get rid of the negatives on both sides. So we'll have 2mn is equal to bx. And so we'll have 2 times the m value of x times the n value. Let's do positive 4 first. So we'd end up with 8x equals bx, meaning that b is equal to positive 8, right? And then if we plugged in -4 for n, the other possibility, we'd end up with -8x equaling bx, meaning that this can also be -8. So those would be the two values of b for this case, right, in part B. And so what are the two, how would the two graphs look like? Well, we would end up either having y equals -x squared minus 8x plus 16, and then this here, it's actually going to factor into x minus 4 squared, or we can have x squared plus 8x plus 16 over here, and then this bracket factors into x plus 4 squared, like that. Right? Those are the two possibilities. And so how are both of these going to look? Well, notice that this one here, it's going to have a vertex at 4 and 0, but notice there's a negative in front, right? We have a negative a value, so it's going to be actually opening down. And then notice that the c value is -16, so it's actually going to go through 0 and -16. Right, so it's going to look something like this. This quadratic looks like that. This quadratic here, it's going to have a vertex at -4 and 0, and then it's still going to have that same c value, so it's going to go through 0 and -16, like that. Right, so those are the two possibilities. This b value can either be plus or -8. And that's pretty much it. So that's the process. So whichever way you're doing it, you may be doing it a different way. You may find this way maybe a little bit tedious, a little bit confusing. It's just we use that same perfect square trinomial formula in the videos before, in sections before. So I'm just continuing on with that. But if you have a different way of taking these quadratics, finding the constants that make them a perfect square trinomial, feel free to use that way. The point is that all of these quadratics have to be perfect square trinomials in order for them to only have 1, 0. Then moving on to part C, so we got y equals ax squared minus 12x plus 9. So notice in this case, instead of solving for the b value like we did in parts A and B, we're going to be solving for the a value now. So I'm going to take this quadratic, let's write it over here. And because we have a negative here, the perfect square, remember there's two perfect square trinomial formulas we could use, so I'm going to use this one over here, like that. And then we could just mix and match these. So again, this m squared has to equal this entire ax squared, right? This term has to equal this entire term. This -2mn has to equal -12x. Like that. And then this n squared has to equal 9. Like that. Okay, so what would happen here is, first off, notice we can get the n values. It could be either plus or minus 3. Okay, and then from these n values, we can actually get this m value from this formula. So now we're going in a different order. Before we had an m value, then an n value, we'd plug it in here. Well, now we're going to be using both of these to get the m value, and then that m value we get, we'll plug it in here. And it's actually not going to matter whether we plug in plus or minus 3 for this n, because no matter what m value we get here, when we plug it in here, we're going to be squaring it. So watch what happens. It ends up being -2m. Let's plug in positive 3 for n. We'll have -12x. So this would end up being -6m equals negative 12x, then divide both sides by negative 6 to get that m value by itself. So this would end up being positive 2x. Then we could take this, plug it in here. So watch what happens. 2x squared equals ax squared. This would end up being 4x squared. Remember, we got to square the 2 and the x. We end up with ax squared. Notice that the a value is equal to 4, right? This and that. And that's the only answer, right? It's not a plus or minus, okay? It's only going to be a positive a value. Remember, a perfect square trinomial, this is going to be positive, this is going to be positive. Only this could be plus or minus that middle term over here. Okay, and so what if we used, instead of positive 3, what if we used negative 3? What would happen? Well, watch what happens. We're going to get the same value because we'd end up with positive 6m equals negative 12x. Divide both sides by 6, m is equal to negative 2x. Well, now we plug in negative 2x over here. That's going to be squared. Negative 2 to the power 2 still gives us positive 4. We don't need this bracket. And then x squared is x squared. Then we got ax squared. The a value is still 4. So whether we plug in plus or minus 3 over here, when we get this m value, it's going to be plus or minus 2x. But when we plug it in here, because we're squaring it, we're going to always end up with a positive 4 over here. So there's actually only one possibility for this trinomial. There's only one possibility for a in order for this quadratic to be a perfect square trinomial. Okay, and so plugging in that a value right there, this actually is going to factor into 2x minus 3 squared, like that. Right? We're going to have one factor. It's going to be squared. I'm not going to go through this process of factoring it. You should be fairly comfortable by now going from here to here. Okay, if you want to though, you can. You could either do it with decomposition. You could also use that perfect square trinomial formula that we have, right? Multiple ways to go from here to here. If you have to go back to the section where we talked about perfect square trinomials, how to factor them, you can do that. Okay, so well, what is the x-intercept going to be here? Well, it's going to be when 2x minus 3 is equal to 0, meaning when x is 3 over 2, or 1.5. And so the way that this graph is going to look, we're going to have 3 over 2 over here and 0. That's going to be the vertex and the 1 x-intercept. And then it's opening up because we have a positive a value, and then it's going through a y-intercept of 0, 9. It's easy to get. It's just the c value for the standard form. And so let's actually label this point over here so it doesn't get in the way of the drawing. So that's how the one possibility is going to look for part C. And then finally, part D, we got y equals 25x squared plus 60x plus this c value. So in this case, we have to solve the c value. So again, let's take this quadratic and let's try to match it up with that perfect square trinomial format like this. So again, m squared has to equal 25x squared. This 2mn has to equal the 60x. And then the n squared is equal to the c value. So let's look at these. What can we get right away? Well, notice over here, right? If we square both sides, square root both sides, notice that m squared, or sorry, m is just going to equal 5x, like that, right? Square rooting both of these over here, right? Because 5x squared is equal to 25x squared, that initial value right here. This can technically be plus or minus 5x, right? The square root of 25 can be negative 5 as well. But again, because we're going to be squaring the n value here to get the c value, it's not going to matter ultimately. but I could show you both scenarios here. So let's say we start off with positive 5x. So we got 2. The m value is 5x. The n value we're solving for, so we'd end up with 10x, sorry. 10xn equals 60x. Divide both sides by 10x to get the n by itself. N is equal to 6. Well, we plug in 6 over here, square it, c value is 36. So a c value of 36 would make this a perfect square trinomial. Right? That's personally the process that I go through. Now, what if we put in a negative 5x here? We'd end up with negative 10x, divide this by negative 10. This would be negative 6, plug in negative 6 here, negative 6 squared still gives us positive 36. So like part C, there's only one possibility for part D, a C value of positive 36 in order for that to be a perfect square trinomial. Okay, so that's pretty much it. So now let's factor this, and you could use decomposition to factor this. You could also use like I mentioned in the previous one. Let's actually do the process for factoring it here. You could also use the perfect square trinomial format or formula. This is going to be m plus n squared. So notice from here, the m value is 5x. From here, the n value is 6. Right? And we're going to be using the positive because this is positive here. And then we could take this and then plug it in for this m and this n. So this is going to equal to 5x plus 6 squared. That's what it's going to factor to. Okay, if you took this and factored it, you'd end up with this. You could also do decomposition if you want. Right, so whichever way you do it, this perfect square trinomial factors into that. And then graphing this, when is this going to equal 0? It's going to happen when x is negative 6 over 5 or negative 1.2. So that's going to be around over here. Okay, it's going to be opening up because we have a positive a value, negative 6 over 5 and 0. We also have a y-intercept of positive 36, which is what we solve for, that c value. So we end up with that right there. Right, so after graphing these, you could see all of them, they only have 1, 0, 1 x-intercept, and it's the same as the vertex. Right, so whenever they ask you a question like this, find constants. So a quadratic only has 1, 0. Remember, the quadratic has to be a perfect square trinomial. In my opinion, I would take the quadratic, match it up with the perfect square trinomial, see what you can get, right, from those different components, and then get that constant that you're ultimately solving for.